we're going to continue with our evidence that came after Alfred Wegener, the evidence that led to the theory of plate tectonics. And it all began with, in 1950s, scientists were able to actually measure magnetism, that is ancient magnetism, which shows the location of rock where it had formed. Like if you looked on a globe, the lines of latitude and longitude where this rock formed could be measured. And so what they actually found is that the continents had shifted in their locations because the the magnetism shows them all in around the equatorial area at the time. So then in the 60s, two geologists, both Harry Hess and Fred Vines, were taking measurements of the seafloor. I think Hess was involved with the Marines, I think Vines as well, and they noticed that the ocean floor was cracked. So they noticed that in the middle of the Atlantic Ocean there was a crack on the seafloor. If we look at this next image, I think we can see it. If you look closely, here's North America, South America, here's Europe and Africa. You can see that there's a whole bunch of volcanoes along the seafloor, and they noticed exactly in this point the seafloor was cracked. And what they also noticed is that the further you get away from this crack in the middle of the ocean floor, the older the rock gets. So they both came together and coined the term for this, seafloor spreading, meaning that there is a crack along the seafloor, and from this location outward, the seafloor or the oceanic crust is moving away from the center. If we look at what a model of this would be like, so remember we had once conjoined continents when we had Pangea, and when you start to move away from the middle of the ocean, and this is what we're looking at exactly here, South America and Africa, these two continents with the crack in the center. So these two continents gradually and slowly moved away from each other. And the further you get from the center of the ocean floor, the older the oceanic crust is. So as these two continents move further and further apart, you can see that here we have a seafloor that's maybe 10,000 years old, here 9,000 years old, 8,000 years old. So the closer we get to the center of the ocean where the crack is, the younger the ocean floor or the oceanic crust is. So, and this is why they called it seafloor spreading. So here we're at ground zero. So this line here, this one corresponds with this crack in the ocean floor, and this is seafloor spreading. The youngest rock is at the center. The further you move away from the rock, the older, away from the center or the crack, the older the rock gets. So they coined this seafloor spreading. Then the next thing that scientists started to do, all geologists began to actually map all the locations of any seismic activity from earthquakes and volcanoes. And here is a pattern emerging. You can see that all along here we have earthquakes or volcanoes, all along here, all along here. So what they then figured out, ultimately, based on all this evidence, is that yes, the continents have shifted in their locations. And yes, the Earth's crust is cracked. Not just the crust specifically. Remember, we talked about you have the crust, and then on top of the crust you have continent and ocean, right? And so we said this is oceanic crust and this would be continental crust, correct? So this is a crust. And we know that beneath the crust is the upper part of the mantle. So these two combine to make that rock layer, the lithosphere. So it's not just the crust that is cracked. This whole lithosphere is cracked. And that's the cracks you can see here exactly. If you follow these lines of earthquakes or volcanoes, you can see exactly where these lithosphere parts are cracked. We call these large areas of cracked lithospheric plates, we call these areas a plate. That's exactly what lithospheric plates or crustal plates. So the lithosphere is cracked into large slabs of rock, or let's put rock slabs, called plates. So that's what we're calling these large pieces of rock. Okay? So these are cracked kind of like a broken eggshell. So our crust, or the whole lithosphere, the crust and the upper mantle, are cracked in the large plates. So these large plates make up what we know and call plate tectonics. Tectonics is motion. So obviously there's some motion going along where these plates meet up. And we already know that because we once had all continents joined together. All right. Where plates meet up, where two plates touch, so this is plate, let's say plate 1, plate 2, plate 3, and plate 4. Where any two plates touch is called a boundary. So where plates touch is referred to as a plate boundary. Okay? Along each and every one of these areas where two plates touch, you're going to have different types of motion, and that's what we're going to talk about as we move on into the plate tectonics part, the motion part. Another interesting fact to note is that some plates, I'm going to add some plates carry only continents. Okay, some carry only water or only oceans. And some carry both ocean and water. Ocean and water. All right, sorry. Ocean and continent. Silly. Okay, so that kind of gives you an overview of where we're headed right now. Real quick, let's just look at a plate map. Now remember, guys, I write, you write, so I hope you have your journal and you're keeping all of these things together with you for the next quiz that will be coming up on this information. All right, so when they found all of this information about the earthquakes and the volcanoes, they started to map the actual plates. So these are the plates we're talking about, each one of these individual. Now look, we've spread the earth flat, so don't be confused. But each one of these individual segments within the darkened lines are plates. Each one of these dark lined areas are boundaries, right, where something happens. We already know that, remember, Hess and Vines, here's the middle of the Atlantic Ocean. Remember, we said that South America has moved away from Africa, right? And that in the middle we have seafloor spreading. So on the ocean floor, we know that there is a boundary where plates are moving away from each other. You can see that's already indicated here by the arrows. So this would be an area where we have seafloor spreading. Okay, and that's pretty much it for now. If you guys have any questions, I'll be on Google Hangouts from 10 to 12 every day for you to ask questions. Other than that, make sure you're in your notebook taking notes. You will need to be printing out materials and following my lead as we move forward. All right, y'all have a wonderful day. Bye.